Hello, everybody, and welcome to episode 80 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Gavin, and that is Fia. And you might notice we are missing a host because Mike is off having some fun adventures.
Go Mike.
Yeah, go Mike. We're very excited for him. He is going to send us a little snippet to throw in here about what exactly he's doing, but he will not be joining us on the pod for quite a while, depending on how long his adventure shenanigans take. But we're super happy for him. Sad that we'll be missing him, at least for us in person on the pod, but super happy that he gets to, go out and adventure a bit.
Yes.
So anyway, here's Mike explaining what it is he's doing.
Hello, everybody. This is Mike. Just doing a quick check-in for everybody out there from I Wish You Were Dead. I'm not going to be on the podcast for a little while, and if it sounds like you can hear me walking around and things are squishing, that's because I am. This summer, most of you guys know that I am a teacher. So this summer, I have taken off. I am not working any of my normal side jobs. I have taken off, and I'm going to try to do the 46 high peaks of the Adirondack Mountains. There are about 46 peaks in the Adirondacks that are north of 4,000 feet of elevation. As of right now, I've done 6. I just did 2 today. Donaldson and Emmons, I don't recommend them. Today was awful, today's bad, and I am not done yet. I am on my way back to do at least 1 more and hopefully 2 more today and then be done with this range. But I just want to let you know that if you are missing me on the podcast, fear not, because Gavin and Fia have it on lockdown. And hopefully, when the school year returns in September, I will do the podcast. But that's just a quick update as to where I am and what I have been doing. Hopefully, I can get all 46 done by the end of the summer, but I'll make sure to keep all you guys updated on the progress. Thanks for checking in, and I'll be sure to hear from you guys pretty soon.
Awesome. So thank you, Mike, for sending us that. I haven't actually heard it yet, so I have no idea what he says.
Yeah.
But so for a little while, it's just going to be me and Fia, and we have some potential guests coming on in the next couple of weeks, potentially. So cool. Hopefully we get all of that worked out. But you might have noticed, based on the title and the number of episode that this is a Fia episode. This is Fia Takes the Wheel Volume 2, which makes my life easy because I don't have to do work.
Yeah.
So Fia, what are we talking about today?
Yeah, so today on this episode, I wanted to share my thesis project with you guys and tell you a little bit what I am working on and what I have been working on for almost 2 years now, trying to get this into a degree, So
I sure do.
Yeah.
Listeners, long-time listeners of the podcast might remember, and I actually had to look this up because I didn't remember. Way back in episode 12 of the show, I talked about my master's thesis, so throwing it way back. So I like this kind of continuity because, theses take a lot of work.
Oh, yes.
And they're worth talking about. So go ahead, Fia. Tell us about your years of research.
Yes. So the title for my project is Do Live Oysters Drive Differences in the Oyster Reef, Benthic, and Nectin Community on Natural Oyster Reefs?
Cool. For the non-super sciencey folks.
Yeah.
What does that mean?
Yes. So, oyster reefs can act as a habitat, and they are a habitat for a lot of different organisms and a community, some would say. And I'm pretty much looking to see if the live oysters on a reef are doing something to that community, influencing them positively or negatively, that just plain old shells or any sort of hard structured habitat can't do.
So basically seeing if the oysters themselves affect the things around them, as opposed to as instead if it was all these shells building up, as if it was just like a
Exactly.
rock outcrop.
Yes.
Okay.
Yeah. And so some terminology in this question, the benthic and nectin community. The benthic organisms are basically anything associated with or occurring on the bottom of a body of water. So the bottom of a body of water is called a benthos. And the animals and plants that live on that bottom are benthic organisms. So these can be things like oysters or worms, any sort of like seagrass or basically things that live on the floor. And then the nectin part of the community are swimmers. So these are critters that are able to swim and move independently of the current. So these are going to be things like crabs and fish. And the reason why I'm honing in on these specific organisms on the bottom floor and either live on the bottom and can swim or just live on the bottom, because one, it's would be way too much for a master's project to look at everything like in like the different parts of a body of water, like pelagic fish or things that feed on oysters when like that are in the air, like birds and stuff. It's way too complicated. So I'm just trying to hone in on a specific area, and also because these things are so closely like spatially to the live oysters that I think that those would have like the most impact in terms of if live oysters were doing something to that community.
Cool. And yeah, it's always kind of tough trying to rein yourself in, right, as to what you can do.
Yes.
Like I remember from my thesis, there was potentially a new species of horse that there might have been enough evidence to support, but I just didn't have the time to get around to that. So I could have named a new species potentially, but that's, just you've only got so much time to do a master's thesis. Exactly. So I definitely hear you there.
Yeah. So we're trying to look at these guys. A little bit of background to start of why I'm curious about this is because estuarine and coastal ecosystems are degrading. Estuaries, they're degrading worldwide, but particularly in Louisiana, it's a big problem because of things like subsidence, human activity, and climate change. So for those of you that don't know, estuaries are where fresh water from rivers and streams meet the ocean. So it's this kind of mixture of fresh and salt water. And it is a great place for biodiversity. A lot of things are able to live in these areas, and it creates a good place for productivity. And cool. So, yeah.
And correct me if I'm wrong here, Fia. Did I hear a geology vocab word in there?
You did. Subsidence. Do you want to kind of explain what that's about?
Sure. So most of the time when you hear about subsidence, it's referring to like tectonic plates. When two plates are moving toward each other, one will subside, which means it like goes underneath the other one, but it generally just means sinking. And so the kind of subsidence that is happening down in Louisiana is because you've probably heard at some point that like New Orleans and that general area are sinking, quote unquote.
Yeah.
And that is absolutely true. When all the sediment that gets dumped down the Mississippi River gets down there, that all has to fall out, and dirt is really heavy. So all the weight, just builds up and builds up down there, and it weighs down the tectonic plate, the North American plate, and makes it sort of sink a little bit in that spot. think about it as if you had like a bowling ball and you just set it in the middle of your bed, how it would make the bed sort of sink a little bit in the middle there. The same thing happens with glaciers. However, normally in areas like the Mississippi River, all of that dirt is supposed to be replaced. So as much as it sinks, there's new dirt to take its place. So it stays more or less level. But we have done such a great job of mucking up everything to do with the Mississippi River that the dirt no longer gets there. We've diverted it and it goes someplace else.
Yep.
So that area is sinking without the new dirt coming in to keep building it up. So now that entire area of, you know, the Mississippi River Delta is just continuing to sink.
Yep.
So really neat geology stuff going on there, but that's not the point of today.
Yeah. I guess fun fact for you, some one of the organizations that does climate stuff in Louisiana has predicted Louisiana's coast to lose about 42.9 kilometers squared each year if we don't do anything about that. And
that's really bad.
Yeah, that's really bad. I think I read
per year. Is that what they said?
Per year, yeah.
Oh my God.
I have this beautiful map that shows you the amount of land loss or gained that maybe we could throw some sort of link to.
Yeah, absolutely.
But yeah, it's a lot if we don't do something about that. So the amount of loss in these ecosystems can have cascading effects on habitats and organisms. This can negatively influence those things by just taking those things away. If you don't have as much habitat, then you don't have as much organisms. And in turn, this can have larger impacts on local biodiversity, meaning the potential for taking away of a diverse array of organisms. And this can eventually have effects on our economy and culture and general survival, because we depend on these systems for things like food, materials, and other services. So, sad news. But anyway, one particular organism.
Yeah, I have to imagine being an ecologist these days is just not as fun as it is. I feel like the bad news kind of outweighs the good.
Yeah,
generally.
It do be sad right now.
Anyway,
but we're trying. So,
exactly.
One of the organisms that live in these coastal estuary ecosystems are oysters. And oysters are sedentary organisms, meaning that once they settle and decide to live, they will not move from that place unless they are moved by something else. Right. And they are unique because they need a hard substrate to attach to in order to grow and reproduce and keep it on. So they start on a hard substrate of any kind, and then they grow, reproduce, they spawn in the water, and then their larval forms will float until they find a hard substrate, which generally is around the oysters that have already settled. And they basically grow on top of each other. So layer after layer after layer of these oysters are forming based on generational recruitment of oysters living their life. And
right. So at first you just need, a single area of rock, and then after that they can just kind of expand on themselves more or less.
Right.
Cool.
There have been some studies that have shown that oyster larvae actually prefer dead shell or oyster oyster shell to recruit onto. Nobody knows really why. They just have found that. They're still looking into that, but
Interesting.
Yeah. So
I would not think that, because I would think the oyster that they settle on would not like that.
Right.
Yeah, I wouldn't like one of my babies, or couldn't, maybe not even my baby, somebody else's kid hanging on to me for their entire life. I don't think I would like that very much.
Yeah. I don't know. Still trying to figure it out,
Interesting.
But yeah, oysters are organisms that can be called this terminology, which is a foundation species. So a foundation species is an organism that is spatially dominant, meaning that it covers a lot of space. It can provide habitat, which I said earlier, it does that for a lot of organisms. It can also alter abiotic conditions, so changing local scale things like temperature, or maybe with oysters, they will kind of attenuate wave energy, so they'll kind of calm down waves that get hit onto the reefs. And they have been shown to have net positive effects on diversity and abundance of other organisms, like the things that depend on them for the habitat. So
yeah, and that's all, broadly true of a lot of different kinds of reef. That's like one of the definitions of a reef, as we talked about way back in Fia's first appearance on the pod.
Yes.
When she was a guest.
Yeah, throwing it back this episode.
Yeah.
But foundation species like oysters, they can support biodiversity through another big term, non-trophically mediated impacts. Non-trophic means interactions that are non-consumptive or eating interactions between critters. So
right. So, like trophic levels is what most people sort of think of as the food chain.
Yes. And they can yeah.
Right.
So basically oysters or any foundation species can affect biodiversity through two ways: through their ways of trophic mechanisms, which is like relating to feeding or nutrition, and their non-trophic mechanisms, which is going to be things like just their hard structure,
or any of those other things that you mentioned, like changing the water temperature.
Exactly.
Yeah.
Basically, changing the environment without actually doing anything with their feeding interactions. So, some examples that oysters and the reefs that they create can theoretically influence the community through is the alleviation of abiotic stress. This is a non-trophic, a non-food way, like attenuating wave energy, like I said, and also through providing habitat. The oyster reefs are really complex in structure, and they have a lot of cracks and crevices like throughout the reef that can provide a refuge for certain organisms, be a nursery ground for little baby organisms, and then also be a feeding area to some predatory species. So it's kind of a benefit for a lot of different groups. And so a lot of people and studies have been published on how those non-trophic, those non-feeding mechanisms of oysters impact biodiversity. General consensus is that oyster reefs will increase biodiversity when compared to things that don't really have a structure, so like mud or sand bottoms that don't really give that structure for hiding and living in to protect them. And
yeah, like the example that I think I was given, or maybe I just came up with it off the top of my head right now. I don't know. But sort of like a single family home can only hold so many people, whereas if instead you had like a giant apartment building, you can fit all sorts of different people.
Exactly. Yeah. It's basically just breaking up the space into smaller spaces.
Yeah.
And so moving on to the trophic or the feeding mechanisms, theoretically speaking, living oysters, can provide food to other organisms. It's been shown that oysters are a food source for mud crabs, blue crabs, and some snails and whelk species. They are also theoretically able to alter nutrients at a small spatial scale, because when they filter water, when the oysters filter water, they basically poop out sediment onto the benthic floor. Yeah, the bottom of a body of water. And so this transferring of nutrients from the water to the bottom can potentially benefit critters that might use these nutrients. Another potential thing, I say these potentially because there's very little to no citations, or I guess no one's really ever proved these things except for like the nutritional aspects of feeding. These other two, the altering nutrients based on their pseudofeces, and then also their ability to alter the water clarity, so how well you can see through water, could potentially alter some feeding or nutritional mechanisms.
Quick question, really quick.
Yeah.
Did you just call it pseudo-feces?
Yeah, that's what they're called.
So the sediment that gets filtered out, that it's not eating, just that it catches by accident, more or less.
Yes,
and
that's their poop.
Quote unquote poops out. It's called pseudo-feces.
Yes.
That's awesome. I did not know that. I'd never heard that before. That's really funny.
Yep. That's what that. I mean, you can't really like say oyster poop, so you got to call it something, and that's what it's called. Pseudofeces.
Interesting. Yeah. No. And there's no way I was just gonna let that go.
Yeah, I try to tiptoe around it. But anyway, so oysters can filter water really quickly, and this can alter the way, I guess, how clear the water is. So depending on how much sediment is running through the water, obviously, but there's potential that if there are a lot of live oysters, then maybe the water's clearer, and this could be a really good opportunity for predators that will hunt with their eyes visually. Clear water means better vision, and then better ability to hunt potentially. So these trophic mechanisms are really what I'm more interested in, because there's really been, I don't want to say significant, but a lot of fewer studies about the trophic stuff than the non-trophic stuff. So trying to tease this apart is really complex stuff, because on one hand you have organisms that are benefiting because the oyster reef is a refuge and a nursery, but they're also a hunting ground. So at some point there's a trade-off between the two that makes the trophic mechanisms of oysters a bit harder to figure out.
Yeah, and I think that just kind of inherently makes sense. I feel like all ecosystems are harder to completely figure out than people might think. Food webs are, just a part of it. And there are so many just like weird chemistry things that like people who don't deal with this kind of stuff every day would just never occur to them. And I can only imagine in a place with so many things going on, that I'm kind of not surprised that there are certain parts of this that nobody's ever published on before.
Yeah. I spent months trying to find something that would be related to this, and I found a few. And those few that I have found basically looked at the relationships of live oyster densities, so the number of oysters and their volume, so how big they are in relation to how big the reef is. So they're kind of trying to see, like, does the number and the size of live oysters on a reef, if there's differences, how does that impact what's using that reef?
Okay.
And just no surprise, all of these research studies have found very mixed results because sometimes the reefs would positively influence a species and then in another place it wouldn't. And it might be context dependent. We don't know. We're still trying to figure out because there's still only a few papers out there that are really looking into this stuff.
Right.
Yeah. So why do I care about all of this? If you were wondering.
Yeah, that's always the question.
Why do I care about all this?
Well, not just that, but so presumably, how a master's thesis ends is you defend it to the people that you are, that more or less your supervisors.
Yeah.
You have for a master's, it's typically 3 people on your committee. Your direct supervisor, somebody else in the department, and then an outside person who really has nothing to do with your department.
Yeah.
And so what they always try to get you with is why do you care? Why should I care? Why should anybody care about this? Because
I will tell you.
and as much as I think science for science's sake is a good enough answer, that probably will not do you any favors when you go to defend it.
Yeah, exactly. I think science for science is a good enough reason too, but apparently that might not be the best for other people and for funding sources as well.
Yeah, that's a big thing, especially with ecology. Paleontology, if you say something dinosaur, you'll probably get some kind of funding from something. Ecology, depending on what you're looking at, oysters aren't the sexiest of threatened groups of animals.
No.
So finding funding sources to study them might be a little bit more of a challenge.
Yeah. So I care about this because oyster populations are declining across the globe. I think it's like somewhere around 90% of natural oyster, or 85% of global natural oyster reefs have already been lost. And that was from 2017.
Oh, wow.
Yeah. Or actually, that was from 2011.
That is a higher number than I thought you were going to say.
Yeah.
Oh, that's even worse. That is a higher number than I thought you were going to say.
Yeah, it do be bad. And even worse, oyster reefs are exhibiting functional extinction, which means they aren't able to have any significant ecosystem role, like how I was saying, providing food or providing habitat, and also persisting at less than 1% of the prior abundances. And so of the global regions that this one study had estimated reef loss, they had identified the northern Gulf of Mexico region to have the kind of least decline in oyster reefs globally. So like the best of the worst situation, because the reefs there are still highly vulnerable to like they're still sensitive. Their predictions again say that about 50 to 85% of the reefs in the Gulf of Mexico have exhibited the functional decline. So even though there are oyster reefs in the area, their ability to provide ecosystem functions like habitat provision and food to the communities is even less than the estimated oyster reef area. So these losses can have really.
I don't know about you, Thea, but that sounds pretty bad.
Yeah, it's pretty bad, and so we should really care about this because it can have a lot of negative impacts on the coastal communities and can decrease biodiversity and have a very bad spiral of things come after. On the bright side, I guess, this loss of natural oyster reefs has sparked a significant amount of resources to invest in oyster reef restoration, especially in Louisiana. The Louisiana CPRA, I think that's Coastal Protection Restoration Association, they came out with a coastal master plan, and this is to restore the coast, and they implement billions of dollars into oyster reef restoration across Louisiana to try and build them back for ecosystem services and also to help kind of against weather and storm events, because like I was saying, they attenuate wave energy, so they kind of act as a barrier for things like the towns and cities that are a little more inland and can be like a little cushion for when we get the big hurricanes.
Right.
And so there's also a lot of efforts from the Nature Conservancy, and then our Department of Wildlife and Fisheries in Louisiana is also doing some long-term monitoring of oysters too. But the ability of oysters to function as foundation species, to provide habitat and have positive effects on diversity, is really ultimately depending on their continued existence, recruitment, so bringing back more live oysters after they reproduce, and then growth, which can be measured by looking at the number of live oysters and the size of live oysters on a reef. If there are decreases in things like the number of oysters and how big they get, this can potentially impact those bottom-dwelling organisms that might use them for their non-trophic or non-feeding relationships, like their habitat contributions, or indirectly through their trophic or nutrient relationships via acting as like
it's a lot easier. It's a lot easier for like a crab or something to hide under a big oyster than it is for a small oyster.
Yes. And although there has been a lot of research showing that the reefs support biodiversity through their structure, we don't have a clear understanding about their live contributions to the community, and have yet to identify any sort of threshold at which live oyster counts or their numbers fail to impact the biodiversity. So that kind of brings me into what oyster restoration looks like right now. In Louisiana, oyster restoration currently most efforts in Louisiana use non-living hard substrate like concrete or just empty oyster shells, and those they'll put them out where they're going to restore with the expectation and hope that wild oyster larvae will just recruit and settle on there. However, trying to build a reef takes, I couldn't give you a number, but it takes a long time for them to settle, grow, and then have babies, and then settle, grow, and then have babies to create this really complex structure of how an oyster reef is supposed to look like. And so if these trophic relationships, the feeding relationships, are important for supporting biodiversity, then it might be beneficial to management plans that build and restore the oyster reefs to incorporate a combination of hard substrate and live oysters onto these reefs to basically optimize the habitat for the organisms and then also help maximize shoreline protection. So that kind of brings me into my main objective, which is to assess the relationship of live oyster density, so the counts, and or volume, the size of live oysters, with the biodiversity on the benthic floor to try and quantify the trophic mechanisms that oysters might provide to the community. Is that clear as mud?
No, I think that makes sense.
Okay. It's a lot of words, I think, that if you don't know what they are, it's hard to explain. But
that's science for you.
Yeah. The main thing is I'm really just trying to see if live oysters are doing something that is important and that we should consider for restoration.
Cool.
And so I'm going to try to do that with 3 aims. I'll look at the community across natural oyster reefs that have different live oyster counts and sizes. So I have 4 natural oyster reefs, and they differ in their general amount of their live oysters. Some have no live oysters and are just shell. Some have large live oysters. Some have a mixture of small oysters and big oysters, and some are newly recruiting and just have kind of small oysters. And so I'm going to try to look at differences in the community across those. I'm also going to try to implement a seasonal aspect of that. So just trying to confirm that if I do find any differences between these reefs, that it's a pattern that's consistently or not consistently occurring throughout the year. So I'll be doing, I'll be doing 4 sampling events. I already did one in the springtime, and I'm coming up this week on my summertime sampling. And then I'll do a fall and winter as well. And then,
awesome.
I'm going to add in some seascape aspects. I did some bottom type mapping. So basically just kind of mapped out what my oyster reefs look like, because the reefs in Louisiana are not really typical of what you would think an oyster reef looks like, because it's mud bottom. So it can range from being just all straight shell, like across the whole reef, or they can be kind of patchy and have like clumps where it's just like straight mud and then oyster reef, and then kind of a mix of like mud and shell, and then hard reef again. So I'm going to try and see if that has any effect on the community too. But that's just kind of like a side aim, not really the big part of the project. And then the the last thing is I'm going to try to see if sampling methods make a difference in how I'm seeing differences across reefs, or not seeing differences, I guess. Because there are, with anything in science, many ways to do things. So I'm kind of comparing. Yeah, I'm kind of comparing a really prominent method that people use, which are habitat trays, and they're basically just these kitchen trays you put on the reef, let it soak for a couple weeks, and then pick it up and pick out all the organisms that have kind of settled onto there. And
wait, so like the like the lunch trays you would get in like school?
No, like dishwasher racks, I guess. So like in any type of restaurants, when they have,
that makes more sense.
Yeah, they have like these like square trays that are kind of like I think like 4 or 5 inches deep. So they have like a rim around them.
Okay.
And I actually ordered those trays like from a kitchen supply company online because that's what everybody uses.
That's funny.
Yeah, I line those trays with mesh bags, so that way when I go to pick them up, I can cinch it closed, and whatever's been hanging out there won't get away when I go to lift it up. I also fill these trays with oyster shell and a little subsample of the reef to try and make it representative of the reef and be able to collect as best as you can natural data. Yeah. So that's something that a lot of studies have already used and have kind of made standard to this community scope of things on oyster reefs. But there is another method which I am really excited about. It's called a suction sampler. And this is an underwater vacuum, which I think is super, super cool. Yeah, it basically just sucks up anything on the bottom and shoots it out into another opening that we like put a bag around to collect everything. And I've tested it out, and it's very powerful. It's very powerful, and it's very fun to use. But shout out to my boyfriend Andy. He 3D printed an attachment to that, so that way we can he like put grates on the bottom, so that way we're not sucking up giant chunks of oyster reef and just only trying to get like the organisms.
Cool.
Yeah, so thank you, Andy, for doing that. I'm really excited to try that out in a couple weeks. So I'm going to look at those two methods because the suction sampling has the benefit of being a one-time thing. You can just go collect your stuff and then that's it. The habitat trays, you have to put out, wait a couple weeks for like the organisms to kind of get cozy in there and then take them out again. And then you have to end up rinsing through all the shell that's been put in there. And that takes a lot longer time. But not a lot of people have tested the suction sampler on the reefs because of how powerful they are and the fact that they're going to be sucking up the reef. So we're going to try and test it out and see how it goes.
I like that. That's really cool.
So I guess I'll wrap it up with some broader impacts that I hope to provide after everything is done. And the first one is to contribute to patterns of foundation species as they decline across ecosystems, because foundation species aren't just oyster reefs. They're things like seagrass or pinewood forests. They're organisms that, provide habitat. And
I know, seagrass is also doing real bad right now.
Yeah, and coral reefs. also foundation species.
Yeah.
We're trying, though. We're trying to basically study them across all types of ecosystems to maybe see if there's patterns that can be generally applicable to all of them. Another thing that I hope to provide is locally updated oyster reef densities and species richness in data deficient areas. The site that I'm working at is on natural oyster reefs that aren't being monitored or really acknowledged at all because they're a private property for the organization that I'm working through, LUMCON, which is the Louisiana University's Marine Consortium. It's they're just kind of natural oyster reefs that are there. I don't know that anyone's really monitoring them or their biodiversity at the scale that I'm trying to do right now. Besides my advisor, that's obviously how I'm getting into all of this. And then my final hope that I want to get out of this project is to go back to the Oyster Reef Restoration projects and help inform them by posing a question of if the restoration efforts should be incorporating live oysters onto restored reefs as opposed to just the hard structure that they're putting out now.
Yeah, I think that would make the most sense.
Yeah, but
because
and
I'm sure that it's more thought out than this, but it kind of seems like, hey, let's just throw some cement into the ocean and hope for the best. I know that obviously it is more complex than that, but
yeah, I do feel like that sometimes too, because some of the restoration projects that I've seen are not doing great, and it's frustrating to see that.
Yeah, I can imagine.
Yeah. So that's pretty much it. That's what I'm working on. It's a lot of fancy terms, but in the end, I'm just rooting for the live oysters, and that's all I got to say.
Yeah, and I think after hearing this, I think we can all maybe root a little harder for the oysters. I know it is much easier to care about the big cool animals that aren't doing great. You know, pandas very famously are an example. But now pandas are doing more or less fine. And yet there are species that are way more endangered or at least threatened than them and who are functionally much more important to their environments that are in, a lot more danger than they are.
Yeah.
Obviously, now that we know, including oysters.
Yes.
And, money is constantly being thrown at things like pandas, but
yeah.
Maybe the World Wildlife Fund or something can throw some oysters, a few dollars every now and then.
Yeah, to the oysters.
But no, awesome. Yeah. Thank you so much for sharing that with us. And
really quick,
I didn't really prepare a dinosaur corner or something. I know I typically have some kind of paleontology thing.
Yeah.
On Fia or Mike's episodes, but I did want to follow up off of last episode about Jurassic World Dominion.
Okay.
A couple things.
Yeah.
It was really funny. So my sister doesn't listen to every episode of the podcast, but listens to a handful. She saw that we uploaded one about Jurassic World Dominion, and she called me and she was like, "I haven't listened to it yet, but what was your thoughts?" And I told her, and she was like, "Okay, good. I'm glad it wasn't just me."
Nice.
She also thought it was really bad.
Yeah.
So it wasn't just us.
Yeah. That's good.
Yeah, and then also a potentially redeeming thing is they announced that with the Blu-ray, when that comes out, they're going to be putting out a director's cut with some deleted scenes and things like that.
Wow.
Which hopefully that can make the movie a little better.
Hopefully.
Yeah,
We'll have to wait.
Yeah. I'm really hoping for some like Zack Snyder cut of, what was it, Justice League, where that was like infinitely better than the original cut, but it was also like 4 hours long. I don't think it needs to be a 4-hour movie.
4 hours, wow. Yeah.
But yeah, fingers crossed on that one. Well, I have no idea when that's going to come out.
We will have to wait and see, yeah.
I'm sorry, you were very robot-y right there.
Oh, no. I'm just, is it still bad?
Nope, you're good now.
Well, I guess we'll just have to wait and see.
Yeah, fingers crossed on that one. I have no idea when that's coming out or how good it'll be, but God. Anyway, enough about that movie.
Yeah.
Thank you all for listening, and thank you so much for preparing this, episode for us, Via.
No problem.
All right, and we will see you all next week with an episode that I don't know what it is yet. Potentially with guests. I'm still working with those guests to figure out exactly what time and week that they're going to be coming on. But I guess until next time, I'll see you later. I don't know how to end the podcast yet.
Bye, guys.
I'm leaving that in. This episode of I Wish You Were Dead was written by Fenella Campanino and hosted by Gavin Davidson, Mike Bryson, and Fenella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.